Hello everybody, this is Cameron Snow with Danomics.com. So in this video we're going to be talking about how to identify Badhole and some different ways we can go about repairing data in Badhole sections. So for those of you who may be new to the industry, one of the terms you'll hear thrown about quite often in logging is washout. So what washout refers to is literally as we're drilling the well and we're circulating the drilling mud, we'll start to erode out parts of the formation, and so you'll end up with a well bore that is actually quite rugose. And so I'm just going to zoom out here in this well, and what you'll see is that up here in the shallow part of the well, we have a caliper that's reading about 8 inches. So the caliper, it's a mechanical measuring tool that tells us the diameter of the hole. So we can see that it's reading right about 8 inches. So that means we're probably drilling this with an 8-inch bit. But we see that there's quite a bit of noise in the caliper. And then in some places the caliper value gets substantially higher. So, here in this section we're, generally varying between 8 and 9, maybe 8 and 10 inches on the caliper. But then we get down here to some sections and we can see that the caliper is reading as high as 13, 14 inches. So that means that the well bore is 8 inches and the diameter is 14 inches. So we have this very large amount of formation that's been washed out. And what that means is, for several of our tools, they need to be up against the formation, and so we're actually, could be reading in some cases a significant amount of wellbore fluid and of drilling mud instead of reading the value of the formation itself. And so here, let's just zoom in here to an area that's quite affected by washouts. And so here we can see coming in to the lower part of the muddy formation and into the top of the Dakota. Here we see that we're getting some of these very high caliper readings. And what happens is we move from density values of around 2.55, 2.6, to all of a sudden we have density values of about 1.85. So if you think about what a density value of 1.85 would mean, that would imply something around a 40 to 45% porosity, which is really something that's just not possible. The theoretical upper limits on porosity are around 36% for a well sorted, well rounded sandstone. That's not compacted, that's clay free, and obviously that's not what we have here. And yet we're seeing readings that in some cases are as low as 1.5, which would push us well into impossible porosity values. So the issue that this presents to us is that if we don't address this, is our interpretation will come out where there will be incredibly high porosity values, and that'll make our interpretation unreliable. So we need to do two things here. First, we need to identify these areas, so we need to flag this bad data. And the second thing that we need to do is we need to try and repair the data, because you can imagine that when we have a lot of this in potential intervals of interest, it means that if we just have to use that poor data quality, that we're only able to give a partial interpretation of the section. So let's start off, let's focus on flagging the data here. So there's a number of ways that we can identify and flag washout. So here we can see some of these washout values, and we see that it goes to very high density values, or very low density values, as well as very high neutron values. And when we look at this on the cross plot, that data is represented by a lot of the data that's sitting out here. This is what we would flag as washout in general. We would of course want to try to do something like color that by the caliper to help guide our eye on what we're calling that. So let's So there we go. Now we can see that our higher caliper values are indeed out here. However, we do have some out here as well. So we can obviously use the caliper as a way to flag data. We can use the density values themselves to flag data. There's also the D-row curve, which is the density correction curve that we can use as a washout indicator. And then we have some other methods as well, such as looking at borehole rugosity. And we, if we're interested in doing it, we can also flag neutron and sonic values as well. So let's get started. Let's take a look at a few of these techniques. So let's start off. Let's say we want to flag some Badhole for our density curve. So let's go ahead and turn on some of our criteria here so we can activate those parameters. So with respect to setting caliper, this can be done on a zone by zone basis, but I find it's often helpful to zoom way out, find what the correct wellbore diameter is, and you look and you try to identify at what caliper value do we really start affecting our data here. And so we can go through and we can set that, and we can see how it changes our flags. So we're going to move that down to 11 inches, and we can see that we start to mark a lot of washout here. And we look at the data and we see, actually we're probably not really washed out here. The curve response is pretty reasonable. We also have quite low D-row values, so maybe that's a bit too low. Maybe we move that back up a bit. Okay. So there we go. So now we flagged some of the most egregious washouts, such as here in the Muddy Formation, as well as in the Dakota, and a few other areas where we have some washout. So the next thing we want to do is we can set the rugosity. This is basically derived from the caliper, so I'm just going to change the scale a little bit so we can see a bit better. And this is one that I find is useful to set on a zone by zone basis. So maybe we can come in here and make some adjustments, try and catch just a few additional washout zones in here, and you'll see as we adjust that, those washout parameters or washout flags update. Same for D-row, so let's zoom in a bit here and set that at about 0.3, and let's put in a value there that flags some additional curve. Maybe that should be a little bit lower. Okay, so now we've started to flag those intervals, and if we zoom in, we can see that we are catching the tops of some of those. So one of the things is that it's always better to flag a little bit less at first, and then try to make that repair, see how that goes, and then we can be a bit more aggressive in certain zones. So here I can see a zone that maybe I want to be a bit more aggressive in, and there we go. We're going to flag just a little bit more washout there. Okay, then once we have that set up, there's a couple of things we'll want to consider. So let's go down to a zone like the Muddy. So here you'll notice that we have a very thick interval of washout, and then a little bit of non-washout, this kind of interspersed. And we should probably be actually flagging a little bit more, so try and clean up the edge effects on that. So we are going to set an additional parameter here, which is to pad out our Badhole flag, and hopefully you can see what effect that has. So toggle that on and off, and by padding out the Badhole flag, that gives us the ability to clean up and try and catch some more edge effects with respect to how we flag washout. Okay, so we may also decide that we want to repair our neutron and our density data. So let's turn on Badhole flagging for those. And generally for these, we do this just based on a value cutoff. We generally want to set a quite high value for that. these curves are generally less affected by washout, but in some extreme cases, such as what we have down here, they are affected, as you can see. So once we have that, so we've now flagged our washout, we now want to look at doing a repair. And so there are some options that we can generally take. So for example, we could decide that, well, we just want to flag washout, but we actually don't want to take any action. That is certainly something that we could do. And you'll see that in this case, let me set all these no action. Okay, so no action, now we've got it flagged, but we're not repairing any of these curves. You can see that our cross plot's unaffected. So let's decide that we want to do a repair. We have opted here to use some machine learning tools to do this, so we can do a repair either by a multilinear regression or by a random forest. Both work about equally well. So here we've turned on doing repair by MLR for the density tool, and we can turn on the same, or we can use random forest, let's say, for the PE curve. And so now we can see the original curve in black and the new curve shown here in red. And you can see that we are getting some spots where we have a bit of a flat spot in our data. We can always try a different method to train that. Yeah, so that actually does look a little bit better using the random forest there. Okay, so now we've got that repaired. And then we need to decide what we want to do for our neutron and our density. So in general, I like to try and do a repair by MLR. See how those results go, and if they're not looking great, then we'll do the repair by a random forest. Okay, so now we've got the neutron repaired, and we're just going to apply a similar repair to the sonic curve here. And you can see that with the sonic curve, our repair has cleaned this up a bit. However, there may be a little bit of edge effect in some places that we want to clean up, such as right here. And so, we can try to do some blending of the curve to clean that up and make it a little bit smoother. And let's just give that about a 2.5 foot taper length, so just a very small amount. And there we go. Now we see that we've cleaned that up, and it's a significantly smoother transition from washed out to non-washed out intervals. And so now going forward, first of all, you can see that now when we look at this data, it's been quite cleaned up, and if we want to see how that looks when we look at what was Badhole versus now, we can see that all these data points that were out here have now all been cleaned up and fall within this data cluster. So we did an excellent job of cleaning up this data into more realistic values. And so now moving forward, we have a nice clean data set with predominantly believable values that we can have confidence in as we move forward with this interpretation. So that is what doing washout identification and Badhole repair is all about. It's about taking some of that spurious data that would have gave us a bad interpretation and putting it back into the realm of reality, so we can end up having a nicer data set to move forward in our interpretation with. Alright, I hope this video was useful to you, and thank you and goodbye.